Good day and welcome once again to our class on sequence convergence. Again today, we'll be proving that certain sequence converges, or we'll be showing that they have certain limits. I take the first example and we're trying to prove that the sequence converges. Prove that the sequence is a very beautiful sequence. 1 plus 2 into 10 to power n over 5 plus 3 into 10 raised to power n converges converges to 2 over 3. We want to prove that it converges to 2 over 3. That implies that we want to show that the limit as n tends to infinity of this beautiful sequence 1 plus 2 into 10 to power n over 5 plus 3 into 10 raised to power n is equal to 2 over 3. Again, for us to be able to prove this, we need to recall our definition for sequence convergence. It says a sequence xn converges to x element of real numbers if for every epsilon greater than 0 there exists a k belonging to the set of natural numbers such that what the magnitude or absolute value of xn minus x is less than epsilon for all n greater than or equals to k. And as I said in the previous example so far, I said the first thing we need to do is to do what? Identify a k that works. You need to identify a k that works. And in order to identify a k that works, we begin from there. The absolute value of xn minus x is less than epsilon. The absolute value of xn minus x is less than epsilon. And what's our xn? That's the sequence we are given. That is 1 plus 2 into 10 raised to power n over 5 plus 3 into 10 raised to power n minus 2 over 3 is less than epsilon. That then implies what? It implies that 1 plus 2 into 10 raised to power n, no, we need to take the LCM, 3 into 5 plus 3 into 10 raised to power n, and that gives me what? 3 into 1 plus 2 into 10 raised to power n minus 2 into 5 plus 3 into 10 raised to power n is less than epsilon. By the time we open that up, what do we have? It gives us what? The absolute value of 3 plus 6 into 10n minus 10 minus 6 into 10n over what? Over 3 into 5 plus 3 into 10n to be less than epsilon. And then looking at it carefully, this can remove that. I'm left with what? Minus 7 over 3 into 5 plus 3 into 10n. Don't forget your absolute value sign to be less than epsilon. And so the absolute value takes care of the minus sign. I'm left with what? Minus 7 over 3 into 5 plus 3 into 10 raised to power n less than epsilon. This is the same thing as writing what? 7 over 3 into 1 over 5 plus 3 into 10 raised to power n less than epsilon. And by the time I do some cross multiplication there, my 1 over 5 plus 3 into 10 raised to power n will be less than what? 3 epsilon over 7. That is less than 3 epsilon over 7. When I take the reciprocal of both sides, 5 plus 3 into 10 raised to power n will now be greater than 7 over 3 epsilon. What do I mean by that? Our 1 over n is less than, well, let's use real numbers now. For example, 1 over 4 is less than 1 over 2. By the time you take the reciprocal of both sides, you have 4 here, you have 2 here. And it shows that your 4 is what? Greater than. And so that's what happens here. When you take the reciprocal of both sides, this side becomes bigger than that side. And then this gives me what? 3 into 10 raised to power n to be greater than 7 over 3 epsilon minus 5. And by the time I divide through by 3, my 10 raised to power n is greater than what? 1 over 3 into 7 over 3 epsilon minus 5. Remember, we want to get value for n. So we take the log of both sides. The log of 10 to power n will be greater than the log to base 10 of what? 1 over 3 into 7 over 3 epsilon minus 5. And by the time we take the log of both sides, we have that our n is greater than the log value. And by the time we take the log value, what do we have? By the time we take the log value, we have n to be greater than the log of 1 over 3 into 7 over 3 epsilon minus 5. But n is greater than or equals to k. Therefore, our k also will be greater than the log of what? 1 over 3 into 7 over 3 epsilon minus 5. But since k belongs to the set of natural numbers, it means that k is greater than 0. Therefore, the log of 1 over 3 into 7 over 3 epsilon minus 5 will be what? Greater than 0. And this becomes what? The log values goes away. We have 1 over 3 into 7 over 3 epsilon minus 5 now to be what? Less than 0. By the time we remove our 3, multiplying both sides by 3, we have what? 7 over 3 epsilon minus 5 to still be less than 0. And if that is less than 0, what do we have next? We have that 7 over 3 epsilon is less than 5. 7 is less than 15 epsilon. That tells us that what? 7 over 15 is less than epsilon. Therefore, our epsilon is greater than 7 over 15. We can now go ahead to prove, because we have gotten a k value that will work. What are the assumptions we will take in order for us to prove? Let epsilon be greater than 7 over 15 and k belonging to the element of natural numbers such that k is greater than what? Remember, we have gotten it here. The log of 1 over 3 into 7 over 3 epsilon minus 5. This will be what? For all n greater than or equal to k. That will be for all n greater than or equal to k. What do we want to show now? We want to show that what? Our xn minus x, the absolute value of xn minus x is less than epsilon. So we begin from xn minus x. Our xn is our sequence, and that is 1 plus 2 into 10 raised to power n minus 5 plus 3 into 10 raised to power n minus 2 over 3. And that will give us what? By the time we solve this, we will get what? Minus 7 over 3 into 5 plus 3 into 10 raised to power n. Absolute value. And then the absolute value takes care of the negative sign. We are left with what? 7 over 3 into 5 plus 3 into 10 raised to power n. But this now is less than 7 over 15. That is less than 7 over 15. But our 7 over 15 is less than epsilon. Since we have said that epsilon is greater than 7 over 15, it means our 7 over 15 is less than epsilon. Therefore, it implies that this 1 plus 2 into 10 raised to power n over 5 plus 3 into 10 raised to power n minus 2 over 3, the absolute value of that will be what? Less than epsilon. And since that is less than epsilon, it means that what? It means that the limit It means that the limit as n tends to infinity of 1 plus 2 into 10 raised to power n over 5 plus 3 into 10 raised to power n is equal to 2 over 3. That means, therefore, the sequence 1 plus 2 into 10 raised to power n over 5 plus 3 into 10 raised to power n converges to 2 over 3. Converges to 2 over 3. I would like to leave us with some questions. I said try this. Given the sequence xn defined as 1 over the natural log of n plus 1 for n belonging to the set of natural number, use the definition of limit of a sequence to show that the limit as n tends to infinity of that sequence xn is equal to 0. Also, find a specific value of k dependent on epsilon as required in the definition for each of 1, when epsilon is equal to 1 over 2, and then when epsilon is equal to 1 over 10. You can attempt that and let us know if you are able to solve the question. If you have benefited anything from this video, give it a thumbs up, share, and like. See you. God bless you.